Last week, scientists proved that time can go backwards, not in a science fiction film, not in a thought experiment, in a real laboratory with real light measured by real instruments. Physicists at a university in Canada fired photons, particles of light, through a cloud of atoms. And when they measured how long the photons spent inside that cloud, they got a number that should be impossible, a negative number. The photons emerged before they entered. Or at least, that is what the mathematics says happened. And in physics, when the mathematics says something happened, it tends to mean something happened. Before you write this off as a quirk of quantum weirdness that has nothing to do with your life, stay with this for a moment. Because the implications of what was measured in that laboratory reach further than most people realize. And they start with something you think you already understand. What is time, actually? Not what does time feel like? Not how do we measure it? What is it fundamentally as a feature of the universe? The honest answer, which most physicists will give you if you press them, is that nobody fully knows. Time is one of the most familiar things in human experience and one of the least understood things in physics. We know that it flows forward in everyday life. We know that it can slow down near massive objects. Einstein proved this, and GPS satellites have to account for it, or they become inaccurate within minutes. We know that at the quantum level, the level of individual particles, the laws of physics, are almost entirely time-symmetric. The equations work just as well forwards as backwards, which means that at the fundamental level of reality, there is no mathematical reason why time has to go forward, the direction of time, the reason your coffee cools rather than spontaneously heats up. The reason you remember yesterday but not tomorrow, the reason broken eggs do not reassemble themselves, is not written into the basic laws of physics. It emerges from something else, something called entropy, the tendency of systems to move from order to disorder. Time goes forward in this view, not because physics demands it, but because disorder is more likely than order, and disorder, statistically, almost always increases. Almost always. Now back to that laboratory in Canada. The experiment did not violate the laws of physics. Nothing in science ever does. What it revealed is something stranger and more interesting, that at the quantum level, the relationship between time and particles of light is genuinely, measurably weird in ways that our everyday intuitions about time cannot account for. The phenomenon is called quantum tunneling. You have probably heard of it, even if you do not know the name. It is the reason nuclear fusion happens in the sun. Particles tunnel through energy barriers they should not classically be able to cross. It is the reason your DNA mutates. Particles tunnel across the molecule in ways that alter the genetic code. It is the reason the transistors in your phone work at all. Quantum tunneling has always been strange, but this new experiment suggests it is stranger than anyone thought. The photons were not just crossing a barrier they should not be able to cross. They were doing it in what appears to be negative time, arriving before they left. So what does negative time actually mean? This is where it gets genuinely exciting and genuinely confusing. And those two things, in physics, tend to arrive together. One interpretation is that the photon was never really inside the cloud at all, that it took a kind of shortcut through reality, a quantum shortcut that bypasses the normal rules about what takes how long. In this interpretation, negative time is not time running backwards. It is the absence of time. The particle skipped over the duration entirely. Another interpretation is more radical. Some physicists argue that the measurement reveals something real about the structure of time itself, that at the quantum level, time does not flow in a fixed direction at all, that it is more like a dimension than a river, that particles can, under certain conditions, move through it the way you might move through space, forwards, backwards, or sideways. If that second interpretation is correct, and this is a genuinely contested question in physics right now, then the universe is stranger than almost any science fiction has imagined. Time would not be the fundamental background against which events happen. It would be something that emerges from events, something that is built rather than given. And here is where it connects to you. Every memory you have is a record of time moving forward. Every plan you make assumes the future is open and the past is closed. Every moment of grief, every moment of anticipation, every moment of regret, all of it is built on the assumption that time has a direction, that what has happened cannot unhappen, that what is coming has not happened yet. That assumption has never been seriously challenged by physics, until now. Not because this experiment proves time travel is possible, it does not. The gap between a photon behaving strangely in a laboratory cloud of atoms and a human being going back to fix their mistakes is enormous. So enormous that it is probably not bridgeable. But what this experiment does challenge is the comfortable certainty that time is simple, that it flows one way, at one speed, in one direction for everyone and everything equally. Einstein already shook that certainty when he showed that time slows near massive objects and speeds up far from them. Quantum mechanics has been shaking it at the particle level for a century. This experiment shakes it again, more visibly, more strangely, in a way that physicists are still arguing about. The photon entered the cloud, and then, somehow, it had already left. The mathematics says it spent negative time inside, and the mathematics of physics, as a rule, does not lie. What it really means about the nature of time, about whether the past is truly fixed, about whether the universe has a direction at all, is a question that nobody has yet answered. But last week, in a laboratory in Canada, something happened that made that question more urgent than it has ever been. A particle of light arrived before it left, and nobody fully understands why.